For generations, astronomers have dreamed of looking farther into space than ever before. Every improvement in telescope technology has allowed humanity to travel deeper into the universe, not physically, but through light that has been crossing space for billions of years. The James Webb Space Telescope was built to push that journey farther than any observatory before it. By detecting infrared light, Webb can see through enormous clouds of cosmic dust and capture the faint glow of galaxies formed shortly after the universe began. Scientists expected these observations to strengthen many existing ideas about how the early universe developed. Instead, Webb delivered something even more exciting. It revealed that the universe may be more complicated than our current models can fully explain. One of Webb's earliest deep space images contained thousands of distant galaxies packed into an area of sky no larger than a grain of sand held at arm's length. Every tiny point of light represented billions of stars and countless possibilities for discovery. As researchers examined these galaxies more closely, they noticed something unexpected. Several appeared surprisingly massive and well organized despite existing when the universe was still very young. According to many galaxy formation models, the earliest galaxies should have been relatively small, irregular collections of gas and newly formed stars that gradually merged into larger systems over billions of years. Instead, Webb detected galaxies that already appeared surprisingly mature. This does not mean modern cosmology is wrong. Rather, it suggests that galaxies may have grown faster than previously estimated, or that conditions in the early universe allowed stars to form far more efficiently than expected. Some scientists believe rapid bursts of star formation could explain these observations. Others think galaxy mergers happened more frequently during the universe's first few 100 million years. There are also possibilities that entirely new physical processes may still be waiting to be discovered. That is how science moves forward. Unexpected observations are not failures of scientific theory. They are opportunities to improve our understanding. Webb has also transformed our knowledge of young planetary systems. Around newly formed stars, enormous disks of gas and dust slowly evolve into planets. For decades, astronomers believed giant planets required millions of years to fully develop. Yet Webb has identified several planetary systems where massive worlds appear to have formed surprisingly early. Some giant planets orbit extremely close to their stars, while others exist much farther away than traditional models predicted. These discoveries are forcing scientists to reconsider how planets are assembled. Perhaps giant planets can grow much faster than previously believed. Perhaps different formation mechanisms operate under different conditions. Every new observation adds another piece to an enormous cosmic puzzle. Another remarkable feature revealed by Webb involves one of Einstein's most extraordinary predictions. Gravity can bend light. When a massive galaxy cluster lies between Earth and an even more distant galaxy, its enormous gravity acts like a natural magnifying lens. This effect, known as gravitational lensing, allows astronomers to observe galaxies that would otherwise be far too faint to detect. Instead of simply blocking distant light, gravity bends and amplifies it, producing beautiful arcs and distorted rings across Webb's images. These natural cosmic lenses allow scientists to study some of the oldest galaxies ever observed. Every image pushes the visible frontier of the universe farther into the past. Yet every answer seems to generate even more questions. Instead of revealing a simple story, Webb is showing that cosmic history is richer, more dynamic, and more fascinating than anyone imagined. And this is only the beginning. As scientists continued studying Webb's observations, they realized the telescope was doing much more than photographing distant galaxies. It was helping reveal the invisible structure of the universe itself. Most of the matter in the cosmos cannot be seen directly. This mysterious substance, known as dark matter, neither produces nor reflects light. Its existence is inferred through gravity, influencing the motion of galaxies and shaping the large-scale structure of space. Using gravitational lensing, astronomers can map where dark matter must be located by measuring how its gravity bends light traveling across billions of light-years. Webb's incredible sensitivity has produced some of the most detailed gravitational lensing observations ever collected. These measurements are improving computer models of how galaxies evolve and how enormous clusters formed over cosmic time. Yet they also remind researchers that much of the universe remains unknown. As Webb continued exploring deeper into space, astronomers encountered faint sources of light unlike anything they had previously observed. Many were eventually identified as extremely distant galaxies, brilliant quasars powered by supermassive black holes, or unusual star-forming regions whose light began its journey billions of years ago. At first glance, these objects appeared mysterious. But science does not rely on first impressions. Every unusual observation is carefully investigated before extraordinary conclusions are considered. Researchers examine telescope calibration, compare independent observations, review data processing techniques, and test multiple explanations before publishing their results. This careful process is what makes scientific discoveries reliable. Sometimes the explanation is straightforward. Other times, new observations reveal that existing theories need refinement. That has happened many times throughout the history of astronomy. When Galileo first pointed a telescope toward the night sky, he discovered mountains on the Moon and moons orbiting Jupiter, forever changing humanity's view of the solar system. Centuries later, astronomers learned that the Milky Way is only one galaxy among hundreds of billions. Then came the discoveries of the expanding universe, dark matter, and dark energy, each transforming our understanding of reality. Now, the James Webb Space Telescope represents another historic step forward. Its infrared instruments allow scientists to observe some of the earliest generations of stars and galaxies ever formed. Every new observation improves our understanding of how cosmic structures evolved across billions of years. Some of today's mysteries may eventually be explained through better simulations, improved observations, and more complete theories of galaxy formation. Others could reveal entirely new aspects of physics that scientists have not yet imagined. Whatever the future holds, the answers will come through evidence, repeated observation, and careful testing, not speculation. That is the true strength of science. The universe continues to surprise us because nature is often far more creative than our expectations. Every image returned by Webb expands humanity's knowledge. Every discovery opens new questions. Every unanswered mystery inspires another generation of scientists to keep exploring. The story of the universe is still being written. And with every new observation, we move one step closer to understanding where everything began, and how the cosmos became the extraordinary place we see today.